The purpose of this video is to walk through the step of the ANOVA F test. The ANOVA F test is used to compare more than two means with independent samples. There is various flickering light in our environment. For instance, light from computer screens and fluorescent bulbs. If the frequency of the flicker is below a certain threshold, the flicker can be detected by the eye. Different people have slightly different flicker threshold frequencies, known as the critical flicker frequency or CFF. Knowing the critical threshold frequency below which flicker is detected can be important for product manufacturing as well as tests for ocular disease. Do people with different eye color have different threshold flicker sensitivity? A 1973 study, The Effect of Iris Color on Critical Flickering Frequency, Journal of General Psychology, 1973, 91 to 95, obtained the following data from a random sample of 19 subjects. There are two columns. The first column lists the eye color, and the second column lists the threshold frequency, CFF. For the first individual who has brown color, they measured the threshold frequency 26.8. For the second individual with brown color, the CFF is 27.9 and so on. For the individual with green eye color, they measured the CFF and it was 26.4. And so we have a relationship between a categorical variable and a quantitative variable, where the categorical variable is the eye color and the quantitative variable is the threshold frequency. Do these data suggest that people with different eye color have different threshold sensitivity to flickering light? In other words, do the data suggest the threshold sensitivity to flickering light is related to eye color? And so again, this is the C2Q case. We are given the stacked data, although they sort the eye color already. We need to group them in unstacked data. What that seems to mean is that we will need to divide the eye color into three different groups for three values of the eye colors in this study. One is brown, another is green, and the third one is blue. For each of these subgroups, we will compute the statistics. Specifically, we need to know the sample size, we need to know the sample mean, and we need to know the sample standard deviation for each group. Suppose we let mu1 be the average threshold frequency of brown eye individuals. Now, mu1 describe the subpopulation. Mu2 is the threshold for green eye individuals, and mu3 is the threshold for blue-eyed individuals. We are interested in whether the different eye color have different threshold sensitivity to flickering light. If the answer is yes, then mu1 is not the same as mu2, is not the same as mu3, because this means that the average CFF is different for each group. Therefore, the CFF is related to the eye color. And so we are comparing three means. And when we are comparing more than two means, we use the ANOVA F test. The null hypothesis for the ANOVA F test is mu1 equals mu2 equals mu3. There are only three values for the categorical variable brown, green, blue. The null hypothesis is the statement of indifference. The alternative hypothesis is mu1 not equal to mu2 not equal to mu3. Next, we compute the test statistics F. The test statistic F will be computed using a calculator. the component in the formula for the F statistic test, or if we were to use a calculator, we would need to know these statistics for each subgroups. That is, we need to know the sample size for brown eye color, we need to know the average CFF for brown eye color, and we need to know the standard deviation for brown eye color. Similarly, we need to know N sub 2, X sub 2 bar, and S sub 2. These are the sample size, the average CFF, and the standard deviation for green eye color. And lastly, N sub 3, X bars sub 3, and S sub 3. We will need to know these statistics before we use the ANOVA F Test calculator. But this is basically exploratory data analysis. Remember how when we have one sample, we compute the mean and the standard deviation using a calculator? This is precisely what we will do with Desmo.com. We only compute the statistic for the first sample for the brown eyes individual. We will leave the rest of those two samples for you to try. Open up Desmo.com, specifying the first list. We will have the total of 3 lists, one for brown, one for green, and one for blue. L sub 1 equals, open the brackets, and input the values, the CFF values for the brown eyes individual, 26.8, 27.9, 23.7, 25, 26.3, 24.8, 25.7, and 24.5. We stop. These are the numerical values CFF for the brown eyes individual. We then compute the mean, the average, by typing MEAN, open the parentheses, and specifying the list that we just used, L sub 1. We also compute the standard deviation at TDEV, open the parentheses, L sub 1. And the mean is 25.5875. The standard deviation is 1.3653. We then record these values. The sample size is 8, X sub 1 bar is 25.5875, and the standard deviation S sub 1 is 1.3653. The remaining samples for blue-eyed and green-eyed individuals are computed the same way. If we do the same thing, we will find that the sample size for green eye will be 5. The average CFF for green eye will be 26.92, and the standard deviation for the green eye sample will be 1.8431. For blue eye color, the sample size will be 6. The average CFF will be 28.1667, and the standard deviation will be 1.5280. Now, this is the final step where we use the ANOVA F test to compute the F test statistics. This free online calculator will not only compute the F test statistic but also the p-value for us in one place. Just Google Desmo's ANOVA F test in any search engine such as Google. It should be the first result. Click on it. The calculator already has some of the old problems. Delete the entry inside the bracket only. N is the sample size. So in this case, we have 3 sample size, and they are 8, 5, 6 separated by commas. M is the mean for each of the sample. In this case, we have 3 means, 25.5875, comma, 26.92, comma, 28.1667. And for the standard deviation, we also have 3 standard deviations. If we accidentally delete the bracket, we would need to type it back in. But the first standard deviation is 1.3658. And again, if we delete it, we have to put in the equal sign and the open bracket, comma, 1.8431, comma, 1.5280. These values should be entered in order. To get the result, we simply open the tab Visualizations and scroll down. We will see the F-test statistics. It is 4.8 rounded to 1 decimal place, and the p-value 0.023, and that is all we need. Again, the F-test statistics in this case is 4.8, and the p-value is 0.023. Compare it to the significance level. We see that this is less than the standard alpha. Alpha was not given, so we use 0.05. Since the p-value is less than alpha, we would need to reject the null hypothesis. And if we reject the null hypothesis, then we would support the alternative hypothesis. And so, in this case, we conclude that mu1 is not equal to mu2, not equal to mu3. This means the CFF depends on the eye color. And so we would answer yes, the data suggests that people with different eye color have different threshold sensitivity to flickering lights.